Okay, for today's session, we don't need to run the SQL files. We're gonna write SQL statements to create tables later. So just open SQL Plus, make sure the service is up and running. Okay, all are ready? Okay, great. Anyone needs time? No? Okay. So for this exercise, you don't need to run any script as before, because we are going to write script. Okay, ready? Managed? Okay then, so let's start. So the first question is, what is constraint as it relates to data integrity? So what are constraints? What constraints are? They are kind of restriction or rules we impose into a database or tables for what? To ensure data integrity. Right? So like, for example, if we're talking about primary key, it's one of the constraints. Then primary key will ensure what? Data is unique, right? And mandatory. Null is not allowed, correct? So in another word, primary key is a unique key, plus it's mandatory and doesn't allow null. Check constraint is another constraint, also helps us to ensure that the data is unique. For example, if we have customer table, so each record represents one customer. Doesn't make sense to have two customers, different customers with the same email address? No, right? So we can impose check constraint to ensure the data is correct, to ensure data integrity, okay? So what are the limitations of constraint that may be applied at column level and at table level? So constraint, there are two types, either can be column level or can be table level. So if you refer back to the URL I shared inside the team from Oracle, so it helps you to differentiate, or you can use it as a reference. So column constraint refer to a single column in a table. So in other words, if you have constraint that you are applying it, if this constraint is being applied to a single column, then this is called column level constraint. If you have table level constraint, which may refer to two or more columns inside your table, then this is considered as table constraint. For example, if we're talking about not null is a constraint, helps us to ensure that the data is being provided to a certain column, correct? So in this case, is this column level or table level? So a not null is applied into a single column, correct? If you want to apply more, then for each column you need to provide not null constraint. In this case, this is column level. Primary key, we apply it to a single column, then this is also column level. But primary key can also be table column, like the composite key. Remember in one of the sessions we talked about composite key, where we had one primary key but imposed into two columns, correct? So this has become, the primary key has become table level constraint. If you are applying primary key to a single column, then it's column level. Clear? Another example is unique. So unique can also be applied on column level, or also can be applied to more than one column, like the case of composite primary key. So you may have also composite unique key. Okay? Foreign key also can be applied to column level. So all the examples we used before was applied as column level. We have one column in a foreign table, right? And then references or link back to a primary table, the primary key in a primary table. So one column to one column. So again, this is also foreign key for the column level. But foreign key can also be applied to table column. That means you have one foreign key on two columns in the foreign table, link back to two keys or to a primary key, composite key in the primary table. So also foreign key can be composite column. Okay? Okay, so again, table constraint allow you to specify more than one column in a primary key, unique key, check, foreign key, all of these. Column constraint refer to only one column. Clear the difference? So back to the question. So you may say that column level is being applied only to a single column. Okay, so the limitation for column level where you apply it to a single column, while table level where you apply the constraint to two or more columns. Okay, if you like to have an example, then you can take not null. Not null is a column level constraint, correct? Composite primary key is table level constraint. Okay? You want me to write it down, or just you can keep note into your question? Or let me just copy them, then I share this file again later with you. So this is for question 2. What do we mean by filled in database? What do we mean by a filled if we say filled in database? Filled means column, all right? You're referring to a column or a cell inside the column. Okay, now we move on. So question 3. Global fast food has been very successful this past year and has opened several new stores. They need to add a table to their database to store information about each of their stores' locations. Okay? So this is they need to add a new table to save the information about their store's location. The owners want to make sure that all entries have an identification number. So now they are telling us what columns this table is going to have. So identification number, date open, address, and city, and that no other entry in the table can have the same email address. So what does this mean? What does this one mean? Sorry? Yes?
The customer or the entity cannot have the email.
Yeah, meaning what type of constraint we need to apply here?
Cannot be sent at the SQL.
Yeah.
And take it at the SQL. Cannot when the
That's correct. But what constraint? What's called? Is it primary key, foreign key, unique key?
Is I think is foreign key, but
Think about it. Have a second thought. Foreign key means you need to have a primary table to link back email address to another table, right? But here they're not asking you. They're not saying there's another table and email address is gonna link back to another table as foreign key. They're saying no other entry in the table can have the same email address.
So this I make here.
Primary key
No.
can, but we have identification number. So ID we already have primary key. So
I think it's foreign key because primary foreign key. No. Yes.
foreign key also no. Just you need to use check key. Unique key. Correct? So we have unique key, you can apply. Unique. Okay? So you can apply unique because they're saying no other entry in the table can have the same email, meaning email address must be unique. Correct? Must be unique. I think I have spelling mistake, right? Unique. Okay? Yeah, but good try. Deserve a chocolate. Okay, so the identification number will be ranging from 0001 to 9999, and it must be integer. Manager is one of the staff, and the detailed information can be obtained from the staff table. Okay, if the date open is not stated, take today's date as a default. Use the following table to create the table needed. So they have already provided us the table. The table name is going to be global lock table. And these are the columns that we're going to have. And the data type already been given to you. The length, okay, nullable or unique, and the default value in case if we need to assign default value to such a column in case that you didn't provide data into it. So if we look here, ID is going to be chart. The length is 4, meaning, what does it mean? Char 4. Yeah, correct. So the maximum size we're going to have for ID is 4. I'll try it doesn't fall on your laptop. Okay. So now we have ID chart. How about name? Varchar 20.
And 20 alphabet.
Yes, correct. Now, what is the difference between char and varchar? Why not just simply having char 40 or 20? Char can? Yeah, char 1 character, but here the length is 4. So we already agreed we're going to enable this column to have 4 characters. Because if you check the ID, it says going to be 0001, 4 character to 9999. Right? So maximum 4 character. But how about varchar? But good try. So char is the data type. The size is by the length. How many character is already defined by the length. Anyone? Longer. Also char, I can make it longer. All right. Okay, so your friend saying he has a point. I mean, varchar probably can store more than the maximum value, but unfortunately, no. But good try. Don't have many today, but that's fine. Okay, welcome. So, we have actually in general 3 types, and not just only in Oracle, same idea if you go to SQL Server. So we have char, we have varchar, and we have nvarchar. All of them accept number of length. So you can define inside the parentheses here n, the number of character each one allows as maximum. Okay? And in case if you exceed, let's say if I say here ID is 4. For ID, the character are 4 only. Maximum character allowed to be entered 4. If you push more, it's going to be trimmed. So only is going to take 4. So for example, if you save ID 1, 2, 3, 4, 5 to the database, only these 4 digits going to be saved. The 5th one is going to be trimmed, taken out, because you already have defined the maximum. So you need to be aware how much the size of your data that you need to store to each and every column. And all applies to the same. So if I say 4 this one, again, cannot save more. If I say 4 to this one, also cannot save more. So now we come back. What is the difference? What is the difference between each one? So for char, let's say if I define char taking 4. Let's take 4, for example. So when I save data into my table, let's say like taking, for example, let's say I only interested to save 1, 2. Only 2 digits instead of 4. So if you check the database, it's gonna save what? 1, 2, and notice where I'm gonna put the close quote, indicating there's 2 empty spaces I didn't utilize, right? Actually, you won't see anything, but just the space is gonna be, the closing quote is gonna be far. And if you count how many spaces are here, you're gonna find 2. Because here you already use 2 spaces for 2 digits, you still have another 2, because you have defined char 4, correct? But if you check, for example, if you define var char 4, and then save the same number, you're gonna see it only 1, 2. Meaning, when we use char, the database is going to preserve the space to you for each cell you are using, regardless whether you utilize or not. These are already pre-reserved to you, 4 spaces. Okay? Whether you assign value or not. For varchar, no. It's going to only reserve the space storage on your disk corresponding to the actual size of your text, of your string. So here I'm only utilizing 2. That means how much space I'm gonna take? If I'm using ASCII code, 2 bytes, right? That means because 2 characters, each character 1 byte, 2 bytes. Here how many bytes I'm gonna take? Anyway, 4 bytes. Okay, you got the point? So this one is gonna take 4 bytes. This one is going to take 2 bytes. So this can be more useful in case you're not sure. I mean, the text can vary in size. Someone has an address, maybe a few words. Another one maybe has longer address, right? If you use this one, you're gonna take a lot of space on the storage regardless, because you're gonna specify the maximum. So let's say we're talking about address and you enable address to 255 character, 255 character. That means regardless whether the address, the actual address for each person requires this actual space or not, is going to be reserved anyway. While this one, no. It only is going to take the size that you have provided. If you've provided 10 character, for example, if I have here 255, then only 4 characters is going to use. If I'm using 10, only 10. If I'm using 20, only 20. But the maximum, 255. Okay? How about in varchar? The only difference between varchar and in varchar is this one, right? In. So in varchar we use when we wish to save characters in Unicode. In Unicode. Because ASCII code has only maximum 255 character. I'm not talking about this, huh? Just if you check ASCII table, you have only 255 characters, including digits, symbols, capital letters, small letters, English, whatever. So you have only 255 characters you can save. How about Chinese language, Arabic language? Then we cannot use varchar. We have to go with nvarchar, because in nvarchar each character utilizes 2 bytes. So that means if I put here 4, and then I save 1, 2. Okay? Then how many bytes should take? 4. If you put 4, gonna take 8 because this is using Unicode. Okay, in varchar, so this one for Unicode. You can use if you are building a system to support multiple language, like probably Chinese, Arabic, rather than English. Unless if you put the ASCII code for your system, usually the ASCII code, let's say if you have English system, that means it's gonna be English language as using the ASCII code. If you need Unicode, then make sure that you use in varchar. So in other words, if your system supports multiple language, use in varchar. Okay? Or like those languages like Chinese, Arabic, also you have to go with it. Because later if you ship your product into customer machine, then they're gonna have problem in text representation. It's not gonna look correct. It's gonna look something else.
Like the language cannot want to set as the end rate.
Yeah, in varchar, yes. So any other language than English, if it's not your main language on your PC, all the time, set as in varchar anyway. Okay? So now we know why it's 2, you need to check Oracle. So Oracle has varchar and varchar 2. So probably they have done some enhancement. Anyway, but the point is same. If you are using char, varchar, or in varchar. Okay? Now for name is varchar 20. Here it says not null. So that means ID must not be null, correct? And actually it must be also primary key. And it's not null by default. Date open, date also not null. So let's start writing the query rather than reading the table. I already written it, but if you like, do you want me to write it again or just I show you the result? Okay, before you decide, in order to create table, because now we are going to create table. So the general statement or syntax to write or create table is to use the keyword create table, then followed by table name, whatever table name you like to give. Then you open round parentheses. Then you provide column definition, one or many definition of columns. It depends on how many columns you have. Then you split between them by comma. Finally, you define your column constraints. Okay? So, you like me to show you this or we write one by one? I think let's write it together. Nicer, right? Then I give you back the file. SQL. So for this one, we need to check. We need to refer back to the table. Firstly, the table name is going to be global loc. Correct? So we type create table global loc. Then we open and close. Now we need to define the columns. What type of columns we're going to get. Then we take care about the constraint, if any. So let's first only focus about the column name, the column definition. So we have ID. The data type is char. The number of character allowed is 4, the maximum. Then we put 4. ID char 4. And then not null. So if you want to refer to make sure this is not null, but this is going to be primary key. So it's up to you. This becomes optional to say not null or null. So I'm going to write it anyway, not null. But if you don't write, that's fine, because this is going to be marked as primary key. And primary key by default is not null. Okay, then we move on to the next one, name. Name is varchar, varchar2, and the data type, the length is 20. This is nullable. It doesn't say anything here. That means name is nullable. It allows to have null value inside this column. So we don't apply not null constraint. We move on. Date open is going to be date. Date opened is going to be date. Then we have address. It's going to be varchar, varchar220. This is not null. NN means not null. So we need to type not null, right? Because according to the table, it says NN. NN means not null. It's not nullable. In addition, we have default, right? We have default value we can assign to this column. So we can say default
is date open before.
Date opened is date. Here. Date open is date. Data type. Also is not null, correct. So we type here not null. Address is not null. The default value is sysdate, the system date.
The date for the table.
Yeah.
Oh, sorry, I'm looking. Yeah, correct. Yeah, thank you. So this one is default sysdate. Then address is not null. That's fine. Then we have city. Varchar2. The size is 20. Also, this one address is 20. 20. And also is not null. Then we go to the zip code. It's going to be number. And the size, we have 5 digits. And it doesn't mention anything. That means it's nullable. So we don't write anything. Then we move on. Phone number. Phone is going to be varchar2, and the size is 15. And it's nullable, so we don't write anything. Then we move on to email. It's going to be varchar2. The size is 20. Right? And then UK. UK means? Sorry? Yeah, unique key. Not United Kingdom, huh? Okay, so unique key. Now we're not going to define constraint yet. Right? So we don't need to mention anything. And unique key, is it nullable or not nullable? Here it doesn't say NN. That means we keep silent. We don't write not nullable. But unique key, does it allow null value? Does unique key allow null value? How many times? Yes. How many times? 1. As long as you don't have it twice. Otherwise, it's going to be duplicates because it says unique. So the difference between primary key again and unique key, primary key doesn't allow null at all, not even one time, not even once. And it has to be unique and mandatory, right? Because it's not null, so mandatory anyway. And unique key allows you only null for one time, right? And of course doesn't allow duplicates. Okay, now we move on. Manager ID is going to be number 4. FK means foreign key, right? FK means foreign key. So we're going to define constraint later once we finish defining columns. Finally, we still have eContact, varchar2. The number of characters are 15. And it doesn't mention anything, so it's nullable, right? It's nullable. Now we're done defining our columns. Now it's time to talk about our constraint, the column constraint that we have. So now we're done with column definition. Now we move on to column constraint. So let's start checking each and every one. What is the constraint for ID? ID is going to be ID. Yeah, correct. So it's going to be primary key. ID all the time. Keep in mind, when you create table, you must, maybe some people might say should, but actually by practice, you must have primary key inside your table. You must have a column give you ability to identify each and every record, right? If you don't have ID, then how you can establish differentiation between each and every record, right? So we need to have primary key. So what we type here, constraint, because now we start to talk about constraint. Constraint, after constraint, you need to give constraint name. So also keep in mind when you define constraint, you type the keyword constraint followed by constraint name. Name of your own. You can put any name you like. But I'm gonna show you there's usually you can follow a systematic way. Because later, based on the name, you can identify this constraint comes from which table and apply to which column. Okay, so we're gonna see. But this is the general idea. So now let's give a name. For the first one, it's gonna be about ID. So usually, what we do, we give name, referring first to the table. So we put the table name, underscore the column, ID, underscore, what is this type of constraint? It's primary key, so we type PK. Again, this is just a name. If you like, name it potato1, potato2, up to you. Okay, just give any name. But if you like a nice way and a systematic way of learning, follow this way. You mention the table name, underscore the column name, underscore the data or the constraint that you apply. In this case, primary key. Why? Because later, if you like to retrieve all constraint from database, you can. But then if you see constraint name potato1, potato2, then where this constraint is applied and what is the purpose, you have no idea. It's going to be very difficult to trace back each and every constraint. But once you see this constraint name later comes out to the screen, let's say because of an error happened, you're not fulfilling the requirement for this constraint, then you see, okay, this constraint comes from table name, global lock, the column is ID, and this is primary key constraint. So easily you can identify the constraint. Comes from which table, applied to which column. So global lock underscore ID underscore primary key. Then we type primary key. Then we specify inside round brackets or round parentheses which column this primary key is being applied into. In this case, ID. Right? ID. Then we put comma. Then we go to the second constraint. What second constraint we have? Not null, we already done. We already defined those not null constraint. We look only for UK and FK. So for unique key, we type again constraint. Then we give name, global, as I said, the column, the table first, then underscore. To which column we need to apply? Email. So we type email. Then this is going to be UK, unique key. Just giving name again, the name doesn't matter, up to you. But try to follow this way, easier for you to trace back the errors. Then we type what? Unique key, and then this unique key is being applied to email column. Next, we have foreign key, correct? Foreign key is going to be also constraint. Again, we give the same name, the same, I mean, systematic way. Then the column is eContact, and this is going to be FK, foreign key. Then we type foreign key. Which column is going to be foreign key? MGR ID, manager ID. So we type MGR underscore ID. Are we done? Is it enough to say this column is foreign key? When we define foreign key, so what we need else? What else do we need? Logically, I mean, if you just think logically, not oracally, if we can say that. When we define foreign key, what you're supposed to have? Two tables, right? One column as foreign key from one table and another column from another table. So we define MGR as foreign key, but linked to what table? So we still need to identify the second hand or the other side of the relationship. So we can say references. So this foreign key is going to reference which table? Which table? So if we check back here, it says staff table, right? Because MGR, it says here, manager is one of the staff, and the detailed information can be obtained from staff, right? So in other words, we need to link back MGR to staff table. So we type references, staff. Inside staff, which table? We are linking back. Here it doesn't mention, but let's assume that it's going to be staff ID. Okay? I'm gonna just break it down to make it easier to see all. That's it. Any question? Any question? Time to test to see if this junk is working or not. Copy, go to SQL Plus, paste, hit enter. Then we get an error. What does it say? Date opened. This is the error here. No need to read everything. Date open, date not null, that's fine. But here it says, it put asterisk. That means the error start at this location, default. Date not null, default. First default, then not null. It's just the order. So you put default, then followed not null. Try again, copy, paste. Okay, now again we got constraint global email UK unique key missing left parenthesis. So actually it's telling us that means you don't need the word key. How I know? Because it says just you need to start with open the parenthesis, the left one. So no need for key here, just unique, and then you apply to which column. Okay, so again, one more time test. Okay, now we're done. Unique key, no more, right? So we already settled that constraint, but we're still not ready yet. What does it say? Error in line 15. This is line 15, where is it? Here. And it's already showing us references staff ID. Table or view does not exist. What does it mean?
Not create a table.
Yeah, correctly. So we don't have a table called staff. We're trying to reference a column to non-existent table. Non-existent table. So if we check to ensure that select from staff, we don't have such table. Correct? Guys at the back, okay? For me to enlarge. So now what we need to do, and that's logical. You are trying to create a table. This table has foreign key referencing another table, but that table does not exist. So in other words, this global lock table has dependency on staff table, and that staff table does not exist. So what you're supposed to do in this case? Yeah, so one solution is you create the table first, the primary table. The primary table is staff. So you create staff table first, then you come back to global lock. Or another solution, you remove this constraint, you take it out, okay? You create your table without the foreign key, then you go back, create staff table, then come back and alter the table, do modification to the definition of the table to add this constraint. So if you like to make alter, so you can also try, there's alter table, then you mention the table name, then you add that constraint. Let's say this one. I can put it in the second one. So in this case, I have to have two queries. So again, this is just option 2. It's going to be longer, but also feasible solution. So option 1, as your friend suggested, we go and create staff table first. Then we come back and create this table second. Or another solution, we create this table without this, so we take this out, so it doesn't cause any problem. Then we go and create staff table. Then we run this command, alter table, and in this case, the table name is global lock, and then add this constraint. Clear? Both are correct. There is no more correct way, because many times you may need to update or change your database. That doesn't mean you have to drop the whole database and then only create the tables from zero. No, at any time you may use alter table to modify your existing table. Clear? So alter is important as well. Anyway, this is second option. You don't want to do it for this exercise, but up to you. If you wish, then can. So in this case, we need to create first staff table. Staff table, we don't have information about staff table here, but the solution has already been provided. So just I'm gonna copy, because the question does not tells us how staff table look like. So for staff table, it's gonna look like this. Oops. Okay, so staff ID, last name, first name, constraint, global location, staff ID, primary key. So you see how we define, by the way, that's a global location. Should be staff. Again, this is just naming. You can't give any name, but it's logical to be staff because we're referring to staff table, then staff ID, the column name, then this is primary key. Okay? Clear? Now, one more thing for foreign key naming, if you like to have proper naming. Okay, we mentioned global location, which is the name of the table where MGR ID exists. But if you like to reference, to show the references as being to staff, then you can also type here staff. So it becomes this table is linked to staff table by the column is eContact as foreign key. Again, this is just naming. This is just convenient way to give names rather than giving just any name, okay? So now let's run this first to create our staff table. I think there's something wrong here. Yeah, I didn't copy properly. It's not working. Okay, so it says table created. That means now my table has been actually created for staff. I can check, select from staff. Now I have the table. It says no rows selected. That means my table exists but is empty. If I need to delete this table, how can I delete? Let's say I want to delete, then I say drop table staff. If I want to remove this table, then I say drop table staff. Now it says table dropped. That means if I check back, select, no more. Table or view does not exist. Now we have to create again. So like we are playing ping pong. Create, drop, create, drop. If you like to drop this one. Okay, now once the table has been created, now I can rerun create table for global location. Enter, and then table created. No issue this time, because staff table has been created. Okay, any question? Any question?
What are the 14th row? The global location server is e-content. Where to find the e-content row?
Again, constraint, you mean this line, right?
Yes, yes.
Okay.
Why have the e-content? Cannot find the e-content.
Oh, sorry, yeah, right. No, eContact is there, but this is not the foreign key. Yeah, thank you. So this one should be MGR ID. Correct? Yeah, thank you. Good. So now how to change? There are several ways. The easy one, drop the table, create the table again. Another way, alter the table, drop the constraint, create another constraint again. So if you like the long way, you can alter the table, alter table, this table, okay? Then you say drop constraint, and you give the old constraint name, the old one, which was eContact, right? Then you create another constraint. Then constraint, then you copy this one again. No, not email. Email, right? No, MGR, this one. Okay, so you have to drop the old constraint, create another constraint. But no need for this way, yeah? For now, especially you are still learning, that's fine. So the easy way, just to drop the table, the whole table, but this one can be problematic. At when? When this can be a problem, to drop the table. Yeah, very good. Now many participants. So you're gonna run out of chocolate today. I didn't expect many participants. Yeah. Who? There? Anyone else? Okay. So we need to drop the table. So correct, if you have data, then it's going to be problematic. Not only data, if this table is linked to other tables. There are many other tables referring to this table. So that means you have to delete also other tables and then come back, delete this table, then create again, then go create back. So it's going to be a hectic journey. So of course, in that case, you cannot drop. The better you go with alter whatever you like. Okay, so for now, just gonna go and drop that table. Table dropped. Now I take the final one, the correct version of my table, then I run again. Table created. Okay, any question? By the way, if we are using database management system, then like those IDE, like Management Studio and etc., when whatever you do on the screen, like create table, there's a query being done behind the scene. But now, because we don't have IDE, so we have to write everything by ourselves. But it's good to have knowledge what's going on. Okay, now we're done with this question. Now we move to the second question. So now, again, just to emphasize, write the create table statement for global lock table to define the constraint at the column level. Execute the create table statement in SQL Plus. Explain why the statement cannot be executed. So we already discussed about this because the primary table, which is staff, did not exist. And we had foreign key. So we had to create first the staff table, only we come back to create the second table. Now, question C. Write the SQL statement that will enter all the data rows in the global lock. Confirm the record have been added. So now you have nice work. You need to insert all this data by yourself by using SQL statement. Okay? So today, instead of having snacks, you can have SQL snacks and sit at night and insert each one of these. Let's do one together to see how we can do it. Firstly, how insert statement look like? So for insert statement, the general syntax is insert into, then table name. Okay? Then you can specify the column that you wish to insert data into. Column names, the list of column names. So I'm gonna just put here if you have a list of column names. Okay? Then values. What you're gonna insert? You're gonna insert values. Then you specify list column values. This is the general syntax for writing insert statement. By the way, this one is optional. Optional. Okay, for example, if we take staff, just to make it clear for you. So I can type here, because we're gonna have staff, insert into staff. Then we can specify we're gonna insert staff ID, right? Gonna insert staff ID, or just let me. What else? We have last name, first name. Then we're done for this section. Now I'm done until here. I already mentioned the list of the columns that I wish to insert data into. Then I type here values. Then I specify the values for each and every column. So for staff ID, for example, it's going to be 1. Last name, let's say Khalid. First name is Lee. So this is how we write a statement. Again, this one is optional, but I would recommend you do this. Why? If you don't write the column names, it's going to be very difficult to know what these values are meant for. Right? Now this is easy. Have only 3 columns. You can remember the table structure. But if you have long table, it's going to be very difficult. So I always recommend you do this way. Though this is optional, but specify the column. Because now you can easily check the corresponding column. Okay, 1, that means staff ID. Khalid is last name. Lee is first name. And so on. So easy to trace back. And this one can become mandatory if you wish only to insert specific column, not all columns. Then you have to specify the column names. This one now is optional because I'm inserting data to all columns inside my database, inside my table. If I don't provide this, also on point number 2, if I don't provide this, you must follow the structure of your table. So that means you have to mention staff ID first. Last name second, first name third. But following this one, it's up to you. If you like to put staff ID at last, then that's fine, and you can change the location. You can put here staff ID 1. Because I already have defined the sequence, how data is going to be inserted. Okay? Yes or no? Okay. What I'm saying, if you don't specify the column names and only you push values like this way, it's correct, but you have to be careful to the sequence of the columns. So here, meaning the first column in my table is staff ID. Second is last name. Third is first name. That means you have to follow the order. So you have to provide staff ID first, then last name, then first name. This one's going to be wrong. But if you provide the column names, then it's up to you. Based on the order here, you need to provide the values. So here, based on my selection, I need to provide last name first, then first name, then staff ID. Then this one becomes correct. Okay, anyway, I recommend you follow this way all the time. Provide the column names, even if you wish to insert data to all of your column, all of them. This is easier for you to understand what these values are. You can just cross-check. Khalid is last name. Okay, Lee is first name. Staff ID 1. So easy for me. Otherwise, you have to check every now and then, go back to the table and see the structure, come back to the insert statement. Okay, so now we go to the long table. This is an easy one. We still need to insert data. So let me just take here, they don't mention for staff what kind of information or data we need to insert. Let me just take from the solution. Okay, so insert into staff. Here we didn't mention column names, but I strongly recommend you do so. Unless you don't have time, like an exam or whatever, then it's up to you. But I'm giving you general recommendation. Even if you are working for a system, for someone else, do this way. Okay, now we're coming back into this later, but this is just for an example here, for insert statement. Now we come to question C. We're working on question 3, part C. So now part C says, write the SQL statement that will enter all the data. So you need to provide all data. Let's start with the first one. Now you already know how to write insert. Then we come here. Insert into the table name, is global lock. Now we provide the column names. We need to insert ID, name. Again, this is optional, but I recommend. We have address, city, zip, phone, email, MGR ID, e-contact. Right? Now we come to insert values. Now what is the value for ID for the first one? We check the table. It's going to be 2589, copy paste. The second value is going to be O'Brien. So O'Brien as a text, we have to put single quote, right? We have to provide single quote. But we have an issue. For O'Brien has special case. Because if you check here, if you type any string, it's going to be in gray color, indicating this is string, right? But once I paste O'Brien names, look what's going to happen. This one will become in gray, and only Brian will become